dual nature of radiation in matter. First will come photoelectric effect. Then after that, dual nature. So in the photoelectric effect, electrons are ejected by photons. So that you are going to learn. And this electron emission by the three methods as I told you, thermionic emission, field emission, photoelectric emission. This is the topic which I am going to explain today. So these all what are the things from this circuit diagram. It is called experimental study of photoelectric effect. With the help of that, some properties we are going to see. First property, second property, third property, okay, fourth property. Then after that, conclusion. These conclusions are going to come now. Okay, up to here you start reading. Then after that, photoelectric effect and wave theory I will tell you. That will be little mathematical explanation is required. Okay. Meantime, I will search for PowerPoint presentation. Easiest way.
Yes, sir. Sir, should I study the experimental?
Everything you have to study because doubts will come only when you study, na. That is the problem. If you have a doubt, I will clarify here. Okay, it is over.
Yes, sir. I'll explain, sir, once.
1 minute. We'll start.
So, I'll just tell what I read, sir.
Okay, right. Very nice. Tell me.
Yes, sir. Sir,
I
for
will ask
photoelectric,
questions, you tell.
so once I just explain what I read.
Okay, right. Tell me.
Yes, sir. So there is a cathode ray tube is there, sir, and then there's a potential difference maintained between the two plates. And then in one plate there are electrons, which then that plate which has electrons is called photoelectric plate. And from there is a light source which emits monochromatic light onto the photoelectric plate. And when the electrons bounce off the photoelectric plate, because of the potential difference in the tube, from the battery they move from one terminal to another terminal. Sir.
What moves?
The electrons,
Very good. What emits?
monochromatic lights.
Monochromatic red light. Okay. That is what it is. What? Why there is a quartz? Why not glass?
Because quartz has free electrons. Sorry, quartz like it polarizes the light. Sir.
No, there is somewhere it is written quartz that I will read it about quartz material, quartz window.
No, in school they mentioned because like if light is of different radiation, quartz converts it to monochromatic. Sir.
Okay, monochromatic light. Where here you have not come across. They have given somewhere.
Yeah, I read the first paragraph. Sir. I didn't.
Complete you are not written. This diagram I have drawn.
No, sir.
This diagram is 2 marks you are going to get.
Yes, sir.
Sure, this diagram and another diagram I will tell you. What is that? Ziegler Marsden experiment. Where is it? Oh, where is that? Ziegler Marsden experiment. It is there, I think. Next chapter. How many types of emissions you studied here?
Sir, I didn't electron emission.
I told you now. You studied this electron emission. Electron emission means what? Electron, where the electrons are generally exist, outermost shell of the
Atoms.
atoms. So those electrons easily we can remove because they are free.
Yes, sir.
Okay, you need to provide some energy so that it will come out from the atom, because electrons has ionization energy, na? Something you have read in your chemistry.
Yes, sir.
So that much energy if you give, electrons will come out. So that is called emission of electron, na?
Yes, sir.
Okay, good. So emission of electrons can be done by 3 methods here in the textbook. One more method is there, I will tell you. So first method is thermionic emission. It means that when you heat the metal, electrons will get energy and electrons will be released from the metal.
Yes, sir.
That is called
Thermionic emission.
okay. Thermo means what? Heat. By heat electrons are ejecting means thermionic emission. Then second one is this field emission. Very strong electrical field if you apply on certain alkali metals, what will happen? They will be remove the electrons. That is called field. Which field? Electric field. How to produce electrical field? How much is the electrical field is required? 10 to the power of 8. On objective type comes. What field is required to remove the electron? They will give 10 to the power of 6, 10 to the power of... yeah, that's... all objective type will come from your NCRT only. Only the thing is, line to line you have to read. Okay.
Yes, sir.
Then again, what it is? Photoelectric emission, which you are studying now. That means when a suitable frequency of photons, photoelectric effect means photons. Photons means it is a packet of energy contains in the light. That packet of energy is h nu. E is equal to h nu. You know, you have studied even in chemistry. H is
Yes, sir.
Planck's constant. Nu is the frequency. The energy, it is actually in modern physics, E is equal to h nu. Planck's theory. With the help of that only we are able to explain the atoms, molecules, nucleus, Bohr theory, or that is Rutherford model. Rutherford model is failed because that is classical mechanics, and Bohr theory is explained clearly the concept of atomic structure. It is because of the Planck's theory. These two theories you have to remember. Rutherford model have you studied?
Yes, sir.
So in that what classical theory they have used, but that explanation was not clear. So what Rutherford said, postulates. Do you remember? If not, next
Um,
chapter I will teach. Okay. If you remember, you tell me. Take a chance to explain.
sir, like you mean the Rutherford's gold foil experiment?
Postulates. Yeah, correct.
Yes, sir. So
Rutherford
like
atomic
if
structure model.
yes, sir. So if you when you emit alpha particles into the gold foil, when they directly like bounce back for a 180-degree angle, that means that the it's hitting on a proton. So protons are there are there in an atom. If they deflect slightly, that means they're hitting the electrons. So and then if they're not hitting it, and then he also said that there's a lot of empty space in between the atoms because some of the rays are directly passing through the gold foil. Uh, that's also
No, postulates I am asking. One postulate you told. In between the nucleus and electrons, there is a lot of empty space, which is compared with your solar structure. The solar
okay,
structure,
sir.
sun is at nucleus, and all planets are moving. So much place is comparison, right?
Yes,
That
sir.
is atomic level comparison. This is the your solar
Yes,
panel
sir.
measurements.
And he also said that like the most of the mass of the atom comes from the nucleus.
Yes, correct. Very good. And why Rutherford atomic theory is failed?
Sir, because electron if Rutherford's model was the this one was sir that if Rutherford's model was true, electron would collapse into the nucleus.
Yes, correct. So, what was the modification done by Bohr theory?
The Bohr said that the electrons don't move towards the nucleus; they move in fixed orbits.
Very good. You know it very nice. Good. Because in chemistry also there and physics also there, na. But
Yes, sir.
you know, physics is too tougher than chemistry. I
Yes,
will
sir.
I will show you one derivation. That derivation, if you know, then you will be going to get more than 75% marks if you are able to do. No, because so much involvement is there. I think whether they taught you or not, I don't know. Are they taught you
Yes.
that energy
Um.
associated by the electron?
I think so, yes, sir. But I don't remember properly.
That is the problem with you. I told you now your teachers are good. The problem is they are not giving more time to learn the student. Here, what is happening? I am sitting hours together, so I am going on asking, so making realization. You know it. This is the Hallmark-Leonard experiment. Okay, with
Yes, sir.
have you studied this? This is the question. Definite comes.
No, sir. I've never heard of that.
Have you studied? I am asking because I am going
No,
to
sir.
ask in the middle.
No, sir.
Study it now.
Yes, sir.
Study it, take time, because you are as long as you read, my computer is on and it will be recorded for you and it will be for others also. Okay? So
Yes, sir.
nothing to worry about the time. Learning process should go. Your class is now learning class, not that my teaching class. I changed it. Okay, just do it yourself, this one, and then come to this experimental study of the, who is this study of the photoelectric effect. You read from your textbook. I will download the PowerPoint presentations, which are very, very interesting. You will understand directly.
Yes, sir.
Are you reading?
Yes, sir.
I somewhere here only, somewhere I'm not getting. I'm just searching. What is that photoelectric effect? So many times I taught that chapter. Desktop, I'll go. You read, na? Don't waste time.
Yes, sir. Done, sir.
Okay.
I can, sir.
Yeah, 1 minute. I will open.
Yes, sir. Sir, at 12 o'clock, can I have like a 5 minute break, sir?
Yeah, take no problem. You can take now also, no problem.
Sir, I just refinish reading this and then.
Okay, right.
Yes,
Not getting that topics, ray optics, alternating, dual nature. So many times I opened here. I'm not. Here, atomic. Here only. Atomic level, atomic nuclear problems. Okay, let me see this. What is there? Okay, tell me what you understood there.
yes, sir. Sir, so what they did was they put they put different lights on metals, sir, on certain types of metal like zinc. But they found out that only UV light made the metal's surface lose electrons. So this showed that like only few certain lights, like such as UV light, will only emit the electrons from the metal surface. And this also showed that the light was made up of small particles called photons. And this because they found out about photons, it had also helped Einstein come up with new definition for photoelectric effects.
Okay, good. But there is a quartz, na. Generally, glass do not allow the UV rays. Quartz will allow. That is what actually I got it now from you. Quartz. Why quartz
Yes,
is used in 1 mark question? They will ask you.
yes, sir.
You understood? Quartz generally not allow the UV rays to pass through it. Only IV rays, that is infrared rays, will allow. Okay. See, then next part is this graphs. First one, what if the intensity of light is increases, photoelectric current is increase. Straight line.
Yes, sir.
Have you
Yes,
studied
sir.
this?
Intensity is directly proportional to.
Yeah,
Yes, sir.
intensity. Then second one is effect of potential on photoelectric current. So what will happen if you increase the potential, photoelectric current will increase. When you decrease it potential, it will one place, it will come to stop. That is called stopping potential. This definition many times it will come. Stopping potential, what will happen? This is photoelectric current, this is the potential at the anode plate, that is collector plate. So here in this one is anode this. Here if we make it more and more positive, more and more current will flow and you can see the current in the ammeter will get more. Okay,
Yes, sir.
right. For different metals, different one. But actually, if you make it this anode as more negative, no electrons will reach to the anode. So current will get
Yes.
stopped. That time potential at anode is called stopping potential. So what is stopping potential? If anyone asks, you have to say that it is the potential at anode for which no electrons are ejected from the cathode and reach the anode. The current in the circuit will be zero. Tell me what I said.
Uh, yes, sir.
Stop.
So it's like when light comes on a metal, it releases some energy, and if you apply some voltage, the electrons stop moving, sir. And when the amount of voltage that is required for the stop electrons is called as stopping potential, sir. Or
Yes,
it's
correct.
also called.
Okay. If the intensity is increasing, Intensity is increases, what will happen? Number of electrons will increase or decrease?
Increase, sir.
Increase. So the
Directly proportional.
stopping potential will increase. That's why the graph you see here. What is this I1, I2, I3?
Um, I don't know, sir.
That's why I told you to read this. This you are not read. I1, I2, I1 is the bulb of 100 watts. I2 is the bulb of 500 watts. I3 is the bulb of 1000 watts. So what do you understand by I? I indicate intensity of bulb.
Yes, sir.
Intensity of, what do you mean by intensity? Number of photons generated by the bulb per unit area is called intensity.
Yes, sir.
That intensity is increasing. What will happen? Current will increase, but they will start from zero only. So
Yes, sir.
that metal stopping potential is the characteristics of the cathode, which is made up of certain material, that is alkali metals, right? So such a material will have only constant stopping potential. Though it will eject a more electron, more current will produce by using different intensity of the bulbs. So three intensities are given here, 1, 2, 3. As the intensity increasing, current will increase, but stopping potential remain constant of that particular metal. This is the graph help you understand. Okay. Next.
Yes, sir.
So at that time, maximum kinetic energy is, this is the formula. This formula you have to, you read this complete, which is very very important, and you tell me how this formula has come. And later I will tell you about these two graphs.
Yes, sir.
This one, this one, you complete it. And if you draw and show, it will be better. You draw this circuit diagram. Okay? This diagram, this graph, this graph. Okay, if possible, you draw this graph also. Complete it up to here. Up to here. I'll give you, after you take 5 minutes break, after that you can complete.
Yes, sir.
Okay. The writing part is I want.
Yes, sir.
Okay, you are there? Hello, Pranav.
Yes, sir. Yes,
Uh,
sir. Sir.
okay, shall we start again? Or
Yes.
you are drawing the diagrams, that ray diagram and all?
Sir, I have to draw now, sir.
Draw it, draw it. Take time, no problem. That is only
Photoelectric effect, sir.
huh?
Photoelectric effect, right, sir?
Photoelectric effect, definition, diagrams, all those things.
Yes, sir.
What is photoelectric effect? Like that. You do it, I will just
Yes, I'll draw it, sir.
draw. Pranav? Pranav?
Oh, sir, my mic was up 5 minutes, sir. I'll finish.
Okay. How much time is required, or may I start PowerPoints? I got it.
No, sir, 5 minutes, I'll finish.
Okay, you do it. In this now, cream of the topic you can understand quickly.
Yes, sir.
This Davison Germer experiment is not there, but your JE that question will come. Matter waves, de Broglie, it is there. Application is there. Total 9 topics is photoelectric effect only. 10th chapter is de Broglie. That's all. May I start?
Yes, sir.
Okay. See, just
So,
read
what
it.
is communicator?
Hmm?
In the diagram, they given communicator. So, what does that mean?
Commutator. That is, you can send clockwise direction current and anti-clockwise direction current.
Okay, yes, sir.
Okay,
Understood, sir.
just read out.
Photons, photoelectric effect, experimental setup and study of photoelectric effect, effect of intensity, frequency, potential, and PE. What is graphical representation and variation of PE current, laws of photoelectric effect, Einstein's photoelectric equation, verification of laws of photoelectric effect based on Einstein's photoelectric equation, applications of photoelectric effect, Matter isn't de Broglie wavelength. Davison and German experiment.
This is not there for CBSE exam, okay? Up to
Yes, sir.
10 only there. Okay, next. Just read out.
Yes, sir. One second.
Where you have doubt, you ask. You go on, read. I want to record.
Yes, sir. Thermionic emission suitable for heating sufficient thermal energy can be imparted to free electrons to enable them to come out of the metal. Field emission. By applying very strong electric field to the metal, electrons can be pulled out from the metal in a spark plug. But photoelectric emission, when light's suitable frequency illuminates the metal surface, electrons are emitted from the metal surface. These photolight regenerated electrons are called photoelectrons. Sir, instead of reading loudly, can you read once and explain later, sir?
No. Read little slow only, no problem. But it should come to me. You will get sleepy if you read yourself.
Yes, sir.
Where is why I am asking you? No, reading, but writing will be taking lot of time. So this is a simple chapter. Easily you can understand. Okay.
Yes, sir.
This spark. Any doubts are there? You will come to know. Na immediately I can reply. You tell me what is spark plug. Where it is?
Sir,
What is this spark plug?
sir, spark plug is like. I don't remember, sir.
No, that is
Like
why I
an
am asking you
art
to read.
sales.
That is why I am asking you to read. This spark plug generally used in car. When you start, na, it will go very high voltage. So that voltage will get give the spark to ignite the fuel. In scooter also you see, if you on button, current will go, and that will give you spark. You might have seen in your YouTube. You can try. You can. Otherwise, I will show you diagram if you don't get. Okay. So this all
Yes, sir.
three over. Got it clear?
Yes, sir.
No doubt. What is photoelectric emission?
So when light falls onto an electric plate, photoelectric plate, it releases electrons. So that's called photoelectric emission.
Wrong. You are telling. You know. You read now. Clearly, you tell.
When light has suitable frequency,
This
it
you are
remains
not
metal
told.
surface. Yes, sir.
That is why I am saying wrong. Many children will go wrong here. That is the reason I am asking you to read. You understood?
Yes, sir.
So suitable frequency is not there, it will not emit. That's all. And so on a metal surface, electrons are emitted. Now you tell me.
So when light of suitable frequency falls onto an illuminated metal plate, electrons electrons come out of the metal plate. So that's called photoelectric emission.
Photoelectric emission is the process in which that suitable frequency of light or photons falls on the metal plate. That you are not telling. Okay, right. Next.
I said that, sir.
Okay, right. Properties. Photon means what are the property? From here you will get objective type in your JE. Carefully read
Yes,
one by one.
Yes, sir. Energy of photon is E is equal to h nu or E is equal to hc by lambda.
Why
So the
lambda?
same
You know
formula
that
is
how nu is equal to c by lambda. You know that, or I have to write?
sir, like the same thing we learned in that process of young double slit tendency.
Okay, no problem. Go ahead.
Um, where h is Planck's constant, v is frequency and the radiation of photon.
What
C is the
is what
speed
is
of
the
light.
h value?
I was going to ask that too, sir.
H value you want, huh?
Yes,
6.4 into 10 to the power of minus 34 kuch hai na, that you have not studied or what? I'll show you. H value, here you can get H value. You see here H value 6.6 into 10 to the power of minus 34. Got it?
Yes, sir.
You remember. Tell me what is H value?
Yes, sir. 6.6 into 10 to the power minus 34.
You are always telling 50% only. Why can't you tell unit also?
Okay, sir.
From here you unit calibrate and tell me.
Joule second, Joule second. Yes, sir. Joule second.
Joule second.
Yes, sir.
I am doubtful. From here you tell me H equal to nu. You are right.
E is in. Yes, sir.
Nu is 1 by T, na?
Yes, sir.
1 by 2 will be coming here. E is joule. Nu is 1 by T. So time is second. Correct. Okay, come on, read out. If you have any doubt, you ask me. One.
Yes, sir. A photon travels at the speed of light c in vacuum. It has zero rest mass, that is, photon cannot exist at rest. Kinetic mass of photon is m is equal to h by c lambda.
This equation, you know, what is the name of this equation?
Sir, E is equal to mc square, relativity equation. Sir.
Einstein relativity. Einstein
Yes.
mass energy relation. Okay, next.
The momentum of photon is P is equal to E by C or H by lambda. How does this equation come, sir?
I will do it. Okay.
Yes, sir.
What is P? You have to tell certain steps.
Sir, momentum, sir.
P, what is the
Mass into
formula
velocity.
P?
Mass into velocity.
Mass into velocity is mc. Correct?
Yes.
Right? Here,
Okay, yes, sir, yes, sir. Understood, sir.
understood? Next. Next.
Yes, sir. Photons travel in straight line. Energy of photon depends upon frequency of photon. So energy of photon does not change when photon travels from one medium to another.
So, what quantity does not change?
Sir, the frequency does not, so energy of photon does not change, sir.
So, energy depends on frequency. Yeah? So, frequency also not change. This is
Yes.
what we have done in your ray optics. Refraction, I told you, na, frequency do not change when it goes from one medium to another medium. Next.
Wavelength of photon changes in different media. So velocity of photon is different in different media.
Where I taught this one, this point.
Last chapter, sir.
Okay, next.
Photons are electrically neutral. Photons do not show diffraction under given condition.
Fraction we have not studied, I will tell you. Bending of
Yes,
ray
yes,
around the corner, that is called diffraction. Next.
sir. Photons are not deviated by magnetic and electric fields.
Here same thing only. Electrically neutral, that's why it will not deviate. Electron deviate or not?
Sir, electrons deviate, sir.
Who explained this? J.J. Thomson.
Uh, yes, sir.
Just now I shown you YouTube video.
Yes, sir.
Next. Photoelectric effect starts now. Come on. That is about introduction. Next.
Yes, sir.
This is the
Photoelectric
definition.
effect, the phenomenon of emission of electrons from mainly metal surfaces exposed to light energy, that is X-rays, Y-rays, UV rays, visible light, and even infrared rays, of suitable frequencies known as photoelectric effect.
Next. Understood?
Yes, sir. Yes, sir.
Next.
Electrons emitted by this event are called photoelectrons. The current constituted by photoelectrons is known as photoelectric current.
So this technical terms you remember: photoelectric current, okay, and then
Yes, sir.
photoelectrons, photoelectric effect. Three things you have to remember for objective type question. Next, here you say
Yes, sir.
UV rays when it falls on the metal. If visible rays falls, metal will eject electrons. Yes or no?
Yes, sir.
No. Only ultraviolet light only metal will eject. Cathode rays or cathode plate is made up of metal, na. So UV rays are required. For UV rays, you need a quartz screen. Then only it will go.
Yes, sir.
Once again, you want to see what is
Yes, sir.
happening
UV rays are falling onto the metal and electrons are getting released.
right here. Visible light. No visible light falls on the metal. No metal or alkali metal. Nothing will come out. So that's why you remember UV rays can show the photoelectric effect. Visible rays shows the photoelectric effect in metals and alkali metal? No. Next year, alkali metals, visible light will produce. Photons will produce.
Sir, why alkali metals, sir?
Alkali metals have less ionization power. Electrons easily it will remove. Electrons are free
Yes,
in
sir.
electrons. Here metals need more energy. So out of visible radiation, visible light and UV light, which is having more energy?
UV light, sir.
You know electromagnetic spectrum.
Uh, I, I forgot. I forgot, sir.
How can you
First
forget,
is
my
gamma
dear?
rays, I think.
Recently, your written test that spectrum. What are the on the basis of the frequency, the and on the properties, the electromagnetic waves are arranged in one pattern. That we call it as electromagnetic spectrum. First will come what it is, very low frequency radio. Then next what will come? That frequencies, the arrangement of the what are the electromagnetic components? Radio waves, microwaves, visible, infrared, ultraviolet, X-rays, gamma rays. Gamma rays are very high frequency. X-rays are next frequency. Highest will be gamma rays. Lowest is radio waves, microwaves, infrared rays, then visible, then ultraviolet, then X-rays, then gamma rays. This arrangement we call it as frequency is called electromagnetic spectrum. It's only two pages chapter that all you remember. It's a very important. Every chapter it will come. Okay, next. This one already you have drawn.
Yes, sir.
This commutator, what is happening? Reversing the current. If you want a negative terminal, you have to reverse using commutator. This is a evacuated glass tube, means this is a glass tube. And this quartz is given because this source is ultraviolet. Visible will allow in glass, but quartz only allow in this one. Photoelectric plate means cathode. It is generally made up of metal or alkali metal. Okay, anode also same thing, metal or alkali metal. So when at a very low vacuum, ultraviolet light falls on this cathode. Cathode reject the electrons. those electrons are attracted because here we have positive terminal. Anode means positive terminal, right? That's it. Right. Next, this is a animation for this. You can see how nicely how to draw also easily shown here. First, you draw a tube, draw a one cathode, then anode, quartz window connected to this high voltage key. When you press it, current will flow, voltage will, here you will get this current, then here voltage will come. Okay, when the ultraviolet rays pass through the
Yes.
quartz, it will electrons will eject. How nicely. And then you can see the reading here. This is called photoelectric current. This is anode voltage, positive or negative. Stopping potential we can take from voltmeter. See here, this is the question asked. Read what it is.
Quartz transmission transmits UV light. When
Glass,
light of suitable frequency falls onto the metallic cathode, photoelectrons are emitted. These photoelectrons are attracted towards the positive anode, hence photoelectric current is constituted.
glass do not allow. You can see this sentence also. Glass transmit only visible light, infrared light, but not violet light. One objective type question comes. I think you might have heard in your school, college. Okay, now may I remove?
Yes, sir.
Now this
Yes,
already
sir.
you have drawn diagram. Intensity increases, current increases. When the potential at anode is increases, current will increase to and saturate. For different intensity, different current. When you decrease, it will come to one voltage. That voltage is called stopping voltage. You can read this stopping voltage.
Yes, sir.
And tell me without seeing.
Sure.
Tell me what is stopping potential.
Okay, sir. So whenever you emit a light into a metal plate, the electrons get released and they get released with certain energy. The voltage required to stop those electrons is called a stopping potential.
Okay, you can see here this one. Here definition you can read. When a negative potential applied to a plate A with respect to cathode, photoelectrons becomes zero at the particular value. That is called stopping potential. This definition is little bit good, they're better than
Yes.
you. What is saturation current? This is saturation. Initially what will happen when anode voltage increases, current also increase. But though even if your anode increases, it will not increase, it will come straight line. This is called saturation current. But if the intensity of bulb increases, then again some more current will increase and saturate. Say next.
Yes, sir.
Next, if you say, then I will go next slide.
Yes, sir. Next.
This is the textbook diagram which I told you to draw. Have you drawn?
Yes, sir. I've drawn, sir.
Okay, good. What is x-axis? What is y-axis?
Sir. Uh, Sir, x-axis is the retarding potential
Hmm.
and y-axis is photoelectric current.
I1, I2, I3.
Sir, I1, I2, I3 are the intensities, sir.
Intensity of what?
Intensity of photoelectric current. So intensity of light hitting the photon.
Ah, you are doing mistakes only. Okay, next. Read this sentence. This loss you are going to get 3
Effects
marks.
of frequency. Yes, sir. Effects of frequency of incident light on photoelectric current. For a fixed intensity of incident light, photoelectric current does not depend on the frequency of incident light because of photoelectric current simply depends on number of photoelectrons emitted and in turn only the number of photons incident and not the energy of photons.
Tell me why it is not depend on the photoelectron current is electrons only. Why it is not depend on frequency?
So because frequency doesn't frequency does not vary with.
So if I vary it, what will happen? Photoelectric current will increase.
Uh, yes, sir.
You read once again wrong.
For a fixed intensity of light, incident light, the photoelectric current does not depend on the frequency of incident light because the photoelectric current simply depends on the number of photons emitted in turn and number of photons incident on the energy of photons.
Tell me in your own language, Kannada. You tell me. I can hear. What do you understand by
No, no,
this
sir,
sentence?
just said in English.
Uh-huh.
Sir, so so incident, the intensity of incident light does not depend on the frequency. It only depends on number of electrons emitted, sir.
If I increase frequency,
Sir, it does not depend on frequency, sir.
why it is not dependent? I want to ask that question.
Sir, because um, sir, I don't know why it's not dependent on
Yeah,
frequency.
because you know that frequency is only energy. Energy only it will provide to electron. Electrons ejection will be only on photons. When photons are more energy, more electrons will release. If photon is less number, less electrons will release. But frequency, what it does, it is providing energy to the photon, not that number of electrons ejection. Tell me what did I say?
So can you repeat once, sir?
You are hearing? No, no. What I am saying you. What is frequency? According to the Planck's theory, energy. It is only energy. It will not emit the electron. It will provide the electron. It will provide the energy to electron. Okay, one electron is there. If you give more energy, it will move fast. Correct?
Yes, sir.
That is frequency. Then what is intensity? Intensity is number of photons. If suppose 100 watts bulb you take, some brightness you will get. If I take 500 watts, which is more brighter? No answer from you. What happened? You are there or not? Hello?
Sir,
What happened? I'm asking you.
Sir, my computer got switched off, sir. Suddenly the charge got over. Now I'm back.
Okay, it is coming up. Shall we continue?
Yes,
Or you are getting bored?
yes. No, no, we can continue, sir.
Even if it is bore, also I have to do, because the time is like that. You are not free, I am free. But when I am free, you won't be free. That is the problem. Okay,
Yes,
anyway,
sir.
I'll start. You understood what I said?
Yes, sir.
Tell me.
Sir,
Or if you want to write, also I will tell you dictation. Or you want to
yes, sir. I'll
grasp.
write one, sir.
You want to write.
Yes, sir.
Frequency is the characteristics of energy of photon. Tell me. Right.
Frequency is characteristic of energy of photon.
Photon according to Planck's theory.
Yes, sir.
Okay.
One second, sir. Straight. Yes, sir. Frequency is characteristic of energy of proton.
It will provide only. It will provide only energy to the electron.
Yes, sir.
Whereas intensity is number of photons. Intensity is number of photons incident on the metal
Yes, sir.
plate.
Yes, sir. Done, sir.
Each each photon eject one electron instantly. Instantly. Each photon eject
Eject one electron instantly.
one electron instantly. If the number of photons increases, number of
The number
photons,
of electrons
it will increase the emission. Whereas frequency will provide the energy to photon only, not eject. So even frequency increases, it does not increase the photoelectric current. So frequency
Yes, sir.
increases, it does not increase the photoelectric current. But photons number increases, photoelectric current will increase. That way you write.
Yes, sir.
What you are written, you just read out. Let me see where I made you clear or not.
Yes, sir. Frequency is characteristic of energy of proton, and it provides only energy to electron, whereas intensity is number of uh, number of photons number of photons incident on the plane, and each photon emits one electron. So number of photons incident increases, number of electrons also increases.
And photoelectric current will increase.
Yes, sir.
Okay, next.
Effect of frequency and incident rate of stopping potential.
Come on. For fixed intensity of light, read out.
For fixed intensity of light, the photoelectric current increases and is saturated with increasing positive potential applied to the anode. However, the saturation current is same for different frequencies of incident light. When potential decreased and taken below zero, photoelectric current decreases to zero, but at different stopping potentials for different frequencies.
Would you like to explain what is the difference of third property and fourth
So can I
property?
just read it? So can I just read it once on my own, sir? Because like whenever I'm reading it
Yeah,
out loud, I'll concentrate more on reading
yeah.
than
Okay, read
understanding.
yourself inside and explain. That is also fine for me.
Yes.
If you don't explain, I will help you.
Yes, sir. Sir, what is saturation current?
This is saturation current. Here you see straight line is coming. Now earlier also I explained in the graph when it is the current is parallel to the potential, that is called saturation current. That current, photoelectric current, is parallel to the potential. At that time there is not increasing any current. That is called saturation current. You got grip on the fourth point or not?
Oh, no, sir, I didn't understood. So fourth point is like the one blue and green, no, sir?
Fourth point is
A blue color and green color.
no, that's graph and this graph. This graph.
Sir, both of them meet. There's a saturation point and there's no saturation point. Sir.
Here saturation point is same for the same intensity of light. Okay, but did you find any difference this graph and the graph which I am showing you? This graph is all current are coming to only one point. That is called at stopping potential. Current will be zero. Am I right? But in this case, what is happening? It is a one stopping potential. It is another stopping potential. Like that, it is coming. See here, three times it is coming. For this is the saturation current. This is stopping potential. This is stopping potential. This is stopping potential. Have you found the difference in the graph or not?
Uh, your saturation current is same for every all of them. Sir, like they all start at different values and meet at the same, sir. But the other one, they start at the same value and they don't.
And that is what I am asking. Why it is so?
But the retardation potential is different for V1, V2, V3, sir. But for there it's same, sir. Another diagram.
No, that why it is same there? Why it is here different? Here, what is
So like,
changing? There, what is changing? Their frequency is same, right?
okay, yes, sir. Their
And
frequency
intensity
is
is
changing.
changing. Here what is changing? Intensity is same. Frequency is
Frequency.
changing. So frequency when it is changing, stopping potential is negatively increasing.
Yes, sir.
So why it is so? Can you give some light on this? Some explanation on this?
Uh,
To stop one hint I will give you. Electrons are ejected with a kinetic energy of 1 joule, right? Another one is
yes, sir.
ejected with 2 joules. Third one is ejected with 3 joules. Which will need more energy to stop, more potential to stop. For more energy to stop, why it is ejecting more energy? Because frequency is increasing. See, first frequency is providing 1 joule of energy to electron. Second is ejecting with 2 joules. Third is ejecting 3 joules. To stop such a energy, we need more potential. Is it not on the positive end? If more electrons are coming with a great energy, you need to stop them. More negative potential is required. Isn't correct or wrong?
Yes, sir. A more potential.
So what you will get? You tell me. Relation between the stopping potential and frequency. Give me one sentence for this. As the frequency increases, tell me.
So as the frequency increases, stopping potential also.
Stopping potential also increases.
Yes, sir.
That is what actually here. There what you got it? As photon intensity increases, photoelectric current is increasing. But stopping
Yes,
potential is remain same in the earlier figure.
understood, sir.
Okay. Now this is a graph. See now, I am coming to frequency x axis, stopping potential y axis. As it is increasing, it will be coming. When the frequency is increasing, stopping potential is increasing. So you got straight line. Why it is starting from here? Why not it is starting from zero? You read and tell me.
Yes, sir.
You read yourself and tell me the answer. If not understood, I will explain you.
Yes, sir.
I'll give 5 minutes time because it is
Yes, sir.
required. What you understood this?
Sir, fifth point I did not understand.
Okay. Meantime, one derivation is there. Will you do this derivation? This is the derivation 3 marks question going to come.
Yes, sir. So today can we end the class by 1:15, sir?
Oh, yes, your wish.
Yes, sir.
See, I am given, I need, what is the time now?
1:05, sir.
Only 10 minutes, huh? Then
Yes, sir.
this you have to complete then. These questions.
Yes.
Again, when you are going to come?
Sir, Tuesday is fine, sir.
Yes. Okay, meantime,
What?
what you do, this is a very simple thing. You try to understand this. In 2 minutes, I'll come. Okay? One injection I have to give to my wife.
Yes,
I'll
sir.
come in 2 minutes because she is not
Yes.
well nowadays. This equation you read, okay? And see the diagram also here. When proton falls, electron ejected instantly. So he is explaining something. If you understand this means one more derivation is there. After that I will leave.
Yes, sir.
Write and show me this.
Yes, sir.
Okay, Pranav, got it?
No, sir. I'm still writing, sir.
That fifth point I will explain now.
Yes, sir.
See the diagram, it will help you in mathematical steps. What is pi?
Sir, flux.
No, no, no. That is the problem. That's why I told you to read carefully. Here it is given already work function pi.
Okay, sir.
Energy required to liberate the electron, that is called pi. Okay, you can see here. Diagram you see. This is the one proton. Two, when what happened? Electrons are ejected. that how much it is ejected, the energy is provided to equivalent to the ionization energy. That is called work function. Ionization energy means what? Energy required to liberate the electron only. Okay, so photon is providing to liberate this electron with certain energy, that is h nu 0, and then again some more energy which is moving with the kinetic energy. So means what is the initial energy? H nu. How many? This h nu is used for two ways. One is just liberating electron, then also providing energy, kinetic energy. Tell me, what did I say? Once again you see,
Yes, sir.
this is the energy given. So some part of the energy is used to liberate electron, that is called work function. Remaining
Yes, sir.
energy is used for providing kinetic energy. It is moving out.
Yes.
So what will
Yes.
be the equation? H nu is equal to,
Flux of rate, sorry, work function plus kinetic energy.
that's all. That is only Einstein equation.
Yes, sir.
You see here, according to flux is equal to H nu is equal to flux this. But H nu is what it is? H nu 0. Nu 0 is what it is? Threshold frequency. What is threshold frequency? Frequency that is minimum energy which is required to liberate electron without kinetic energy.
Yes, sir.
Minimum frequency required to liberate electron. That is called H nu 0. H nu 0. Nu 0 is what? What is nu 0? It is not V, it is nu 0.
Yes, sir.
What is nu 0?
Sir, initial velocity.
Again velocity you are saying.
Sorry, frequency, sir. Sorry, sir.
Not initial frequency, it is threshold frequency.
Okay.
That is why I told you to read here.
Yes, sir. Yes,
Here, threshold frequency. Fifth point you are asking, but these are all things you don't know. I told you to read now.
yes, sir.
So, just the graph shows that it will start with nu 0. That nu 0 is called threshold frequency.
Yes, sir.
Okay. So, below which electrons cannot be ejected. First law understood, you said. Second understood. Third you understood. Fourth you understood. Fifth one is you just read. The process of photoelectric emission is instant. Is this I told you, instantaneous process. One proton, one electron, immediately it will release. No time lag. No answer from you. You got it answer?
No, sir.
No, fifth one. Fifth one got it?
Okay, yes, sir. Yes, sir. Yes, sir.
I told you na in the beginning itself.
Yes,
I
sir.
told
Yes,
you
sir.
instantaneous process
I
means.
didn't understand the sentence.
Okay, right. Next, anything? One to one process also I told you. One photon, one electron it will reject.
Yes, sir.
And this is a law. What is the law? This one is very important, my dear. Next class I will teach. You want means I can teach now itself, but you have to open your mind properly. Shall I?
I'll read it once. Yes, I read it once, sir. Now can you explain?
No, understood.
Sir, can you explain once again? I read it once, sir. So if you understand better, if you understand, I read it.
Yeah, you
If you
just tell me
explain,
what is clear for you, then I will add there.
sir,
There are two
everything is
types
clear.
of physics, Sonay. One is basically from the Newtonian physics, that we call it
Yes,
as classical physics.
quantum physics.
Another one is quantum physics. Quantum physics is modern physics. Modern
Yes,
physics means this Planck's physics. E is equal to h nu. This is a Planck's one. Okay, understood.
yes, sir.
So according to classical mechanics, what happened? It is a continuous of any energy if you provide to the metal, it will absorb continuous. Okay. So is given its picture continuously absorption of energy from the radiation could not explain independence of the maximum kinetic energy on intensity. He could not explain that maximum kinetic energy, but according to the modern physics or quantum physics, it is very clearly explained that energy given to the electron, it is some energy is used to liberate it, remaining energy is used for providing maximum kinetic energy, right? So each proton
Yes, sir.
carries energy and momentum this much, which depend on the frequency of incident light and not on the intensity. All queries which I taught you just now, you told you that intensity increases, generally what they will do, immediately they will say number of electrons increase. That is wrong. That is classical physics. But according to the quantum physics, each electron will eject by its photon. But energy is depend upon the intensity photon. That is frequency of photon. Clear?
Yes, sir.
Okay. Anyway, one more question comes. So now you do it. This I think it is clear now. H nu pi this half mv square, and pi value is h nu 0. H is you take it minus here, h common, nu minus nu 0. Correct? What is nu? What is nu 0?
Sir, mu is the frequency and mu zero is the limiting threshold frequency.
Which is greater for photoelectric equation?
So the frequency is greater than threshold frequency.
Yeah, if it is same, will
Then
you get photoelectric? Will you get
no, sir.
no? If it is greater, only photoelectric. If it is less,
Still you won't get.
won't get no photoelectric effect. That is what actually happening in the metal with visible light. In the visible light, if you fall, what will happen? There is no electrons will eject because the electron metal has more kinetic energy, more ionization energy to liberate electron. Okay, now you realize this. This actually you understood already because pi equal to h nu 0. This is textbook derivation. Clear?
Yes, sir.
And this is clear. This is what actually you have to understand. How this has come, my dear? Kinetic energy is equal to E V0. V here, V is stopping potential. Don't confuse this one, nu and V0. Nu 0 is threshold frequency, is equal to work function by Planck's constant. And kinetic energy is EV0. This how you got. I will just wanted to check your second chapter. If you are good enough, you will tell. Otherwise, no. I have to teach that second chapter also. Come on, recollect, recollect. Let me see your knowledge, deep knowledge of second chapter.
Uh,
You said first chapter, second chapter taught by one of the tuition master.
Yes, sir.
And then what is potential? What is potential definition?
Uh, Sir, the
Electron volt I taught you. You remember?
yes, sir.
This is also called electron volt. 1 electron volt is equal to what?
Yes, it's
What?
yes, I don't know. Sir. The work done to require unit positive charge from infinity to given point
That is what it is?
potential.
Potential. Okay, very good. So V is equal to what is the formula? V is equal
Uh,
to V is
I
equal to work done by charge. Correct?
yes,
Charge is
yes,
here E. So what will be the work done? W is equal to E and V. Correct? Here
yes, sir.
V0. Here it is W0. Correct na?
Yes, sir.
So work done to bring the charge from infinity to that point is working. So it is defined by work done by charge. Work done by charge, which charge here? Electron. So electron
Yes,
into potential will become K maximum. K maximum is kinetic energy maximum. How you will get kinetic energy maximum here? We know that one equation we have done just now. This equation H nu is equal to pi 0 minus H nu is equal to what? Pi 0 plus K maximum. Right? That way. Understood, na?
yes, sir.
Right. Now K maximum is what it is? EV0 here. And H nu pi this is. If frequency is greater than or equal to 0, you will get this. But here what it is? V0 is equal to stopping potential. Stopping potential is H by E into frequency. Again E will be multiplied first H nu also, pi 0 also. So this is the equation. But this one will become constant. This value is constant. H by E is what it is? H by E is frequency is constant. Important result. Let's predict that V0 versus V curves straight line. The slope independent of the nature of the material. This slope help you to find out the Planck's constant value.
Understood, sir.
Okay. You do it and show me this. That's all. Problems are there, then we will do later. Shall I continue or stop?
Sir, it's 25, sir.
Up to what time you want?
15, sir.
Over, na?
Yes, sir.
Then you tell me stop it.
Yes, sir.
Okay, bye. Okay.
Yes, sir. Thank you, sir.
So you just, I will forward this material. You just
Yes,
go whenever free, 15 minutes, you just read line by line. You will get very good marks. Later I will check you. Okay? Okay, bye. Good day.
Thank you, sir.
Welcome.